Here we go. We're going live first. I will check to confirm that we're going live. Okay, that looks good. Just check Twitter too. And we are live on Twitter. So we're going to go ahead and kick things off. Hello, everyone, and welcome to the next episode of Zymposium. So today we're going to talk about building distributed systems on Golem. And in particular, we're going to take a look at how we might build a distributed system like Twitter's backend using the primitives that Golem gives us access to. Golem is an open source platform that we've designed to dramatically simplify the task of building and deploying highly scalable, highly reliable distributed applications. And it does this through something fairly new called durable execution. And Golem's type of durable execution is transparent, so it's invisible. You don't have to write to any SDK. You just run your code on Golem, and you get the benefits of persistent state and sort of transactional execution of your code. And I think you'll see today how it just totally changes the way you architect complex distributed applications. So joining me today is first up Danielle Torelli. Welcome, Danielle. Danielle is winner of the past two Golem hackathons. Congratulations, Danielle, for not only winning one hackathon, but for winning two hackathons right in a row. Please go ahead and introduce yourself for our viewers today.
Hello, everyone. Thanks to be here. Yes, I participated in the last two Golem hackathons, winning the last, and it's a pleasure to be here. Thank you. I have experience mostly in Scala. My professional experience is mostly in Scala. Even though in my spare time I'm giving it a Rust. And yeah, it was my first time actually with the last Golem hackathons to write some, we can say, almost production ready code. Anyway, any real life code that is not some just test or learn code. And yeah, it was very surprising as an outcome as well for me. So thank you.
Thank you for that introduction, Danielle. So Danielle, the last hackathon he won actually was building a Twitter backend on top of Golem, hence the topic of today's discussion. And up number two, joining us today is Afzal Taj, who works on Golem full-time. And he is also the author of a very fascinating and incredibly interesting project called Timeline, which is, I think, one of the only implementations of this paper called Timeline that attempts to create this compositional way of doing event-oriented analytics. Afzal, would you like to introduce yourself for our viewers today?
Hello, everyone. So this is Afzal. As John mentioned, full-time working in Golem for the last 8 months and almost with Golem for the last 1.5 years in various ways. I've been a fan of functional programming before, but for the last 1.5 years, I've been playing around with Rust and Golem and really enjoying the time. And as John mentioned, yes, these days I'm working in a project called Golem Timeline. It's an implementation based on a paper that was released in 2023, where they try and focus on specific set of really hard data engineering problems, which is currently being solved using Spark and PySpark and Flink and other systems that you already know about. But it's more of squeezing those technologies into the problem rather than the other way around. And that's always has been suboptimal. It's really hard to maintain. And finally, they came up with this right primitive called as Timeline, which allows you to compose. It's basically a DSL, but allows you to compose your problem in a very concise way such that it's really easy to maintain. But not only that, it is not much more performant, and the whole design, the backend, has been changed as well. It's a completely different take on these problems. For example, how much time did a user spend rebuffering the video, ignoring the one that came in within 5 seconds after the seek event? Or was there a transaction when in 5 minutes when the locations were actually 20 kilometers apart in using a credit card? So lots of problems in various domains can be solved using timeline. And we found that the right backend that gels well with the idea of timeline was Golem. And that was a fascinating moment where I kicked off that project. Obviously, it's a big ambition. There's a lot to solve.
You're just reinventing
However,
Spark and Flink and a lot of other things while you're at it.
yeah, but yeah, but the fundamentals are correct. I strongly believe in those fundamentals, and rest are just details. And hopefully, we'll pull that off.
Yeah, that's fantastic. All right, thanks for that introduction, Asal. All right, so today, how I thought we might proceed is by talking a little bit about what makes building a Twitter backend so challenging. And then maybe we will turn it over to Danielle, who can show us the architecture he came up with when he decided to participate in the hackathon and build a Twitter backend, or at least a part of a Twitter backend, on top of Golem. And then we'll look at sort of some of the trade-offs that his architecture makes. And then maybe we'll, if we have time at the end, we'll go ahead and brainstorm on how we can maybe improve his architecture even more to better take advantage of some of Golem's strengths. All right, so Twitter architecture. What is the big deal about Twitter? Why is it so hard? Why did Red Planet Labs, when they decided to show off the capabilities of Rama, their DSL for building data-driven applications on the JVM, why did they pick Twitter? There's something really, actually a number of things I think really, really challenging about implementing a backend for Twitter. But they all start, I think, really with the scalability requirements on Twitter, right? Because if we were building a Twitter backend on top and designed to only scale to maybe thousands of users or hundreds to thousands, maybe even tens of thousands of users, then what would that look like? And what would some of the core challenges that we run into be like? Like, how long would it take us to build something like that?
Yes, I think Twitter per se is quite easy, right? And if we would like to build it as a monolithic application, it will be very easy to build. Just we will incur into some scalability issues pretty immediately. And this is what actually happened, I think, in real life with Twitter when they started with their first version. They built it around MySQL and Ruby on Rails, and they had scalability issues. So I thought indeed about making this architecture, and I will share my screen about this architecture. I wanted to
maybe before
mostly,
you dive in here,
yes,
Danielle, we could spend a bit of time just sort of brainstorming. Like, if we don't care about scalability, right? We're just going to build a Twitter backend and we have an afternoon to do it. Then we're going to focus on, I think, what would perhaps be the most essential features of a Twitter backend, which is like you have lots of users. Well, not lots because we're not concerned with scalability, but you have some number of users, right? So that becomes what? A table in
yes,
Postgres, right? So you have a user table, you have a bunch of users in there, and then you have this concept of following, and that's one user follows another user, and that has implications on what you see when you log into Twitter. So you log into Twitter, and
right,
the view that comes up is the timeline view, and in the timeline view, you see the tweets from all the people you're following, and they're all sort of arranged chronologically. So I can choose to follow people, I can choose to unfollow people, but if I follow someone, I'm going to see their tweets together with all the other tweets of all the other people I follow, arranged in a chronological fashion. And then, of course, the other two things that you can do, or you can post tweets on your own Twitter account, which means your followers see them. And then you can share tweets, in which case, again, your followers see them in chronological order. So if I'm thinking about, we have an afternoon to build a Twitter backend and we don't care about scalability, obviously we're using Postgres or
Yes,
SQLite, something like that. We've got a users table. We've got a tweets table. And then we need somehow to represent the follower
followers.
followee relationship. So we probably have another table for that.
Helper table, yes,
It's like a relational, it's like a relationship or edge in the graph table. And you have
exactly.
follower, followee, and so you can contain any sort of combination in there. And then we've got to implement some sort of REST API that allows us to, maybe REST API, but we've got to implement some sort of functionality that allows us to not only post new tweets, maybe share them, but also importantly, generate that timeline view for
Yes,
every user. And so as we're thinking about how we would do that with Postgres, like it doesn't seem that hard, does it? Right? If
it's
we're,
not, doesn't look like it's hard. It's a bunch of join queries. And
yeah,
obviously, you can immediately probably foresee some scalability issues there. Because
yeah,
if you want to poll on that table, then for even a lot of users, or maybe not even a lot of users, but continuously polling on those tables uh, will lead to joins, and then you will have your timeline that essentially is for all the people that you're following, fetch their latest tweets and combine them chronologically, right?
okay. So we're thinking that the basic structure of the back end code that generates the timeline is join, basically join all the tweets together from all the people you're following, sort them in chronological order, and take some number.
Yes,
If this is a paging API, then you skip some number and you take some number, so offset limit, and then you return that to the front end, which then shows it. Something like that, right?
yes,
Which is probably not going to be a fun SQL query to write, but it doesn't seem like it's going to be requiring a PhD in rocket science either. So it seems like the core challenge of generating that timeline view using Postgres or SQLite is actually quite simple. It doesn't seem like there's a lot of meat to that if we're totally ignoring scalability. But that doesn't scale, right? It doesn't scale for a number of reasons. We've got the join, which is an n-way join. So the more followers you have, the more joins are going to be involved in that. And then we've got the sorting, which sounds nasty and is going to
yes,
require indexes, which are going to be costly to maintain. And then we've got the whole process of extracting out a subset of that timeline, the subset that the user is currently looking at as they're sort of scrolling through that, which sounds also not very fun.
and we have only one database. It's not distributed database.
So basically, the naive way to do Twitter, as simple as it might be, is impractical. Like it's not feasible. And but this is why I love this problem because it's like so easy to solve, right? And if you're only concerned about business logic and not scalability, you probably could build a decent Twitter backend in an afternoon. That's probably not unreasonable if you don't
Absolutely.
care about scalability. But the moment you add scalability, you take what becomes a few simple looking queries to a Postgres database and you turn it into something that's almost like intractable. It's that level of difficulty that you're looking at. I don't know how big Twitter's engineering team was in the peak before Elon Musk came on board and fired everyone, but I believe that there were hundreds, maybe thousands of engineers working on building that system. And if you consider the scale, it kind of makes sense, right? Because I think at peak, Twitter sees or saw, I'm not sure if it still does, but like tens of thousands of tweets a second. I think that's reasonable. 10,000 new tweets a second. So you're looking at such a incredible volume. And then you've got users. I think they have hundreds of millions of users on there. Maybe not all of them humans, but hundreds of millions of users. And then you have these other, I think, really interesting where I can follow as many people as I want. I don't think there's a limitation there. So once you add all of these different constraints, like how does Twitter solve them? Right? How do you go from Postgres sort of toy implementation that you can build in an afternoon to something that can actually satisfy the scalability requirements of real production grade Twitter?
Yeah, well, essentially distributed architecture. That's the way you would like you want to have some service-oriented architecture. This is what they actually came up with pretty soon. As soon as they they started having issues, like service-oriented architecture, they use Scala, and you started using Cassandra, if I remember well, as a distributed database. So you can immediately see there that they took the road of distributing everything. That makes complete sense because you want your user to not fall into one only Postgres database or one only API. It cannot scale, as we said.
Yeah, makes sense. So if we were not going to use Postgres and we were not going to use Golem, but if we were trying to solve this using sort of best practice modern day techniques, what would we do in order to sort of solve the timeline problem? We would dump tweets at what in Cassandra, or any ideas on how we might solve this problem using sort of modern
I think
infrastructure?
Microservices would be the key, and possibly keeping a very good cache of your data immediately accessible.
Probably
so you don't
caches at
overload.
probably caches at sort of every level to avoid putting too much, because Twitter's mostly, it's a read only. I mean, not read only, but it's read dominated, because like producers produce their 1% of your overall user base and the consumers are 99%.
Yes.
So probably you tremendously benefit from caching levels. And then you still have, I think, really interesting challenges around, okay, we're trying to generate the timeline view for this user. Obviously, we can't scale that using SQL joins. Even if we use a distributed database, joins, n-way joins are not going to work, and sorting and all that sort of Postgres approach are not going to work. So we have to craft special purpose architecture for every different feature or view of Twitter. Has to be special crafted using things like Cassandra and Redis, maybe Kafka and whatnot. And it comes at great cost, architectural cost, but also probably lots of code handwritten, because at that point you're re-implementing your own sort of database like thing, right? What you could do with SQL in an afternoon, you've got to recreate that, but at the scale of planet scale, so to speak, where your data is widely sharded and where you're going to have to implement your own caching strategies, your own indexing strategies. You're going to have to stick some things in memory and other things in persistence, and you're going to have to really, you are in effect implementing your own sort of distributed database like thing, that is a specialized, highly specialized implementation of one or two SQL queries, basically what could be one or two SQL queries. And so I think it's that aspect which makes implementing a Twitter backend so outrageously complicated.
Yes, obviously, and you also see there how many components we are already introducing. So a lot of things can go wrong in all of this.
Right. There's the operational aspect to it too, and not just operational, but you've got to have people working on and maintaining this gigantic distributed system and microservice architecture like Twitter did, so they have resiliency and other sorts of nice features. Adds even more overhead, more people, and then more ways for things to fail at runtime. And then you've got to keep all of these different pieces of architecture and every single microservice, you've got to keep them all running. You've got to have observability. It becomes outrageously complicated, I think, for not very great reasons. I mean, obviously, it is what it is. You can't have a relational database that scales to these levels. So the goal, the dream of just being able to solve this with a little bit of SQL is probably not realistic. So you're going to have to do something custom. But the fact that you have to go to these extreme lengths to build something that's ridiculously complicated and highly engineered, just to increase user count and tweet count, the fundamental problem that Twitter solves is easy, but actually solving that in a way that scales is quite challenging.
Yes, totally.
All right. Well, now that we've talked a little bit about how Twitter's architecture has been tremendously complicated from the scalability requirements, maybe you can give us, because you actually built a Twitter backend, but not using, I would say, enterprise proven, like best practice modern cloud infrastructure. You used what I hope is next generation cloud infrastructure, the Golem open source project. Maybe you can give us a sort of high level overview of what the architecture you came up with looks like for solving that fundamental problem of users can follow users, and we have to generate this custom timeline view for every user. And also,
Yes, of
tell
course.
us what database you used, if any. Like, did you use Cassandra? What did you use? How did you solve that problem? Basically, assume we don't know anything other than maybe what a Postgres solution might look like.
The beauty of Golem essentially lies also in this thing. We talk about many services, Cassandra, Redis. What I used, data structures. So you keep everything in memory. And we discussed, for example, what are the main actors with the main functions that we want to give to users. So of course, we want to handle users, we want to handle tweets, and we want to handle timelines. So I thought to build essentially dedicated components. And maybe here I can share my screen.
Yeah, that'd be great.
I came up with this ASCII art here. I think it's pretty essential, but gives you the idea. So there are components for handling users, components for handling tweets, and timeline.
And maybe we
And
should talk a bit about what components are in Golem. Asal, you want to fill folks in on sort of what are the fundamental primitives that Golem gives you when you're building an
Yes.
application?
Yes. So Daniel is now talking about straight away implementing Twitter using Golem. Two important things that the users need to get familiarized with when working with Golems is components and workers. Components are just basic building block of applications with Golem. And it's not really Golem specific, rather it's more or less WebAssembly specific. So you can build say a Rust project and compile it to Wasm, and then we can simply call it as component for those who want to really know what exactly technically is component. Once you have that component, you can create an instance of that running in whatever platform. In our case, it's a Golem platform. And we call that instance a worker. And if we have these two concepts ready in our hand, I think we are almost on board into the basic concepts of Golem, I would say. Is there anything more to add, John?
So a component is kind of like an executable.
Yes.
And a worker is kind of like a running instance of an executable, which we might call a process. So like you might have one executable, but you have 1,000 processes that were created from that. It's not just the code. The process is not just the code, but it's also all the state that sort of running process is accumulating over time as it's responding to outside interaction and interacting with other systems. And so that's the component. Basically, we should think of code or sorry, a component as being like a compiled part of our overall application.
Yeah.
And then a worker is being a stateful, actually running, executing instance of some component.
Yes. And not to
All right.
mention that component is highly observable. You can really literally know what exactly that component is doing and what are the requirements of that component in the host and what are the features of the host that it is using, giving you all layer of security for free, which is not going to happen when you simply use a Docker image, which you can do anything and just
Yes.
containerize it. So there is a huge difference in various aspects between component and other similar concepts in the software industry. So, and there is a lot more to it, but we don't have the time to go in depth for each of those details. But yeah, I think this must be enough for us to
Yes.
understand what Daniel is going to talk about.
Enough for now. Okay, Danielle, please take it away.
Okay, so then we have this set of components, right? So user manager, tweet manager, timeline manager, and each one of them, as you explained, it's basically a logic piece, a logic module that handles the specific functions dedicated to, in this case, user, tweet, and timeline. There can be many then instances, so many workers that handle many users, a portion of the users that we have. Specifically, there is a 8-bit hashing function that I came up with because I wanted to actually shard the data of the user across different nodes. And yeah, so basically, if we have a user ID and the user ID is passed through this 8-bit hashing function, then this maps that user ID to one of these workers, specifically to one of those IDs that we have here. And then we will know that for user, I don't know, user ID 1, then user manager 2, tweet manager 2, and timeline manager 2 are the responsible one that handle this data.
So you're basically talking about, okay, there's a lot of data in a Twitter-like system, and you're saying, well, one of the things we need to do is chop that data up into what would be called a shard, and all these different shards are going to be responsible for storing data for a range of users or tweets, etc. And you're going to be using this hashing function to essentially look up, hey, which shard, and a shard would be a running worker, right?
Yes.
In Golem's terminology, it'd be a running worker. And so you're going to store, it sounds like you're going to store, you did store all of that information in memory just as sort of, in-memory data structures.
Yes, essentially in-memory data structures for user profiles, user tweets, and then user timelines.
Okay, so you've got in memory, you've got a number of different shards of this user and tweet data. And in memory, they're storing the user data and the tweet data. Well, obviously, if you tell someone out there that you implemented Twitter like this, they're going to look at you like you're crazy, right? Because, well, what happens when a shard goes down, right? What happens when a shard goes down? You were storing all this data in memory. So first off, you must have to implement some sort of supervision to keep these shards running. And if you're just storing data in memory, then obviously when a shard goes down, even if you bring that shard back online, it's going to start out with empty memory. So when I hear an architecture like this, it seems like it's just a catastrophic, like catastrophically bad choice. It basically, you've got to implement a whole bunch of things which you probably didn't have time to do in the hackathon. What makes this a sound choice, if anything, or does it have all these problems?
Yes, so running on Golem makes this, let's say, good design because we know that workers can be resumed, so their state can be resumed, and but maybe not always, but let's say in memory, there is this persistent state that lasts till when that worker exists. So normally, when you will build something like that into the real microservice world, at least you will want maybe to have a replica for the shard for the node, and you will want to have some code that handles failures because you want to call maybe your shard and that node is down, then what you do, right? Maybe, yeah. So as you said, sounds pretty dangerous to do in the microservice world, but with Golem, it's not.
And it's not because Golem is giving us, first off, each one of these workers, if there is a problem on that machine or there's maintenance or restarts or whatever, then Golem handles the process of detecting that event and restoring that worker, that running worker, on another node from the point where it left off execution seamlessly in a way that's invisible to us as application developers. So that's how we can rely on, if that node goes down, the server is restarted, the CPU catches fire, it doesn't matter. The state of that worker is just sort of transported magically by Golem to a new machine, and we don't lose any information. So it sounds like you use sharding here, just like any distributed database would use sharding, right? You would Cassandra sharded, all the big sort of NoSQL distributed databases use sharding. And so you had to solve the problem of how do we find this person's data, right? Which shard, but you didn't have to solve a lot of other problems that a database like MongoDB or Cassandra, et cetera, has to solve, which is the problem of how do we guarantee these shards are always available and always contain the information in memory that they should have. So we didn't have to solve any persistence challenges. We didn't have to solve any reliability challenge. The only problem you solved here is sharding this information. And then you're relying on Golem to take care of reliability and persistence and all of that stuff behind the scenes. And your application code, presumably, we haven't seen it yet, but presumably it looks quite simple and it's just storing stuff in memory and it's not even worrying about any of these failure scenarios.
And it's beautiful because it's basically the essence of your code, right? You have your data structure and you have the logic around it. Having those guarantees that Golem is providing makes your code you have to just think about your business logic. You don't have to think about almost anything else. And it's very beautiful, allow me to say.
Fantastic. Well, don't let me distract you from your presentation. Go ahead, continue to present this to us.
Right. So then I built a router component. This essentially because there was a limitation at that time. I think it was fixed. Correct me if I'm wrong. But you couldn't have cyclic dependencies between workers. So, for example, I needed a component that was able to just take the requests of the users and then forward them to the appropriate worker. That could be user manager, tweet manager, or timeline manager. And then, just respond with the data that is requested. So, for example, let's go maybe straight in to see the beauty actually of the code. So when you write, is my font size good enough?
Looks good.
Or
yeah,
perfect. So essentially, what you store in memory? Well, you store a tree map, right? That goes from user ID to user struct. Where user struct, for example, in user manager, user struct contains username, profile picture, your followers list, and your following list. And you can see already how essential this makes your business logic, because you're essentially just communicating with a in-memory tree map, right?
So the state we're looking here is the state on a single shard or worker that stores data for a range of users.
Exactly.
Okay. So not all the user data would be stored on this one worker because a worker fundamentally runs on one node somewhere, right? You don't know in Golem where it runs necessarily, but it runs somewhere, and therefore it's subject to the memory limitations as well as CPU and performance limitations of running on a single node. So you have here lots of workers to store all this data. Each worker, which runs on a single node, stores the data for a range of users,
A range of
basically,
users. Exactly.
which could be
Yes.
in the limit, it could be a single user. Each worker could store
Potentially.
data for a
Yes.
single user.
Exactly. And similarly, I will not maybe show the other managers, but you can imagine something very similar to this.
Yeah.
Maybe just the one that is worth to see is the timeline.
So just one quick
Yeah,
issue we should talk about here. So this is a map, right? This is
right.
just a map. It's not a persistent data structure. I know a lot of people are going to be thinking, okay, well, you're storing information in memory. Do you have to call some Golem SDK function
No,
to persist this and guarantee that it's going to survive faults and failures and restarts and everything?
actually not. This code is totally transparent to Golem, so you essentially
That
don't.
seems too magical, right? You're updating stuff
No,
in memory and it's just in memory, and yet it can survive regardless of what happens to the underlying machine or server that it's running on. It seems extremely magical. I think people are going to have a hard time
seems
wrapping their head
extremely
around that.
magical. Yes, but it seems extremely right. This is how it should be. Allow me to say,
Yeah.
in my opinion, of course. And
Yes.
yeah, so there is no interaction with Golem. What is provided, the guarantees that are provided are just on the working part of this code. So when this will be a node that will be working, that will be guaranteed to exist, and that state will be guaranteed to be persisted and live till when that worker is running.
Yeah. All right. So go ahead and continue with your architecture.
Yeah. So just briefly,
Yeah.
what happens when you follow a user? So the router calls the user manager of the responsible user ID. So that node that handles that user data and adds the target user ID to its following list, and vice versa. It will do the same to the followers list of the followed user. And then it calls the timeline manager. Here is what basically we are um, preemptively computing the timeline for that user. So if the followed user will have any tweets or will post any tweet, we will already have the timeline manager pre-computing its timeline.
Okay. All right.
And of course, there are countermeasure actions, compensating actions here to handle failures. So if we have to call different managers. So I feel like maybe this is a residue of my microservice experience that we write compensating actions, but
Yes.
probably is not even needed. But anyway, yes, this is what happens. So the essential part, you focus essentially on your business logic when you're developing this code. So you bind the follower user to the follow user, and you pre-compute the timeline. And unfollow is essentially doing the reverse of this operation. What happens when a user posts a tweet? Well, simply that tweet is posted, and then timeline manager is called to make sure that all its followers have the timeline pre-computed again. This is what I presume Twitter is doing as a background processes. They have a lot of background processes going on, continuously recomputing the data that here we do when a call is actually made for simple reasons to keep the just essential code. Essentially, we had 2 days to build that. So
Yeah.
yeah, and then the query just fetches the data. I mean, when you want to query the user tweets, so you go to that profile and then you want to see the tweets of that user, then essentially it's a list fetch. And how you fetch timeline? Well, essentially, you ask to the timeline manager responsible of that user that you want to fetch the timeline of to give you the timeline. And that would be presumably the most up to date. We don't have, I mean, yeah, eventual consistency in microservices would be a thing, but here we are pre-computing on both of those actions, so it's not needed, obviously. Architecture is very, very simple, allow me to say, but at the same time, it's thanks to Golem guarantees. It will not be like that if Golem will not guarantee all these things. We will already be discussing databases, probably,
Yes,
or Kafka or something like that.
for sure. Yeah. So basically, you implemented all of this without any databases or caches, just relying on Golem's guarantee to have durable state in all of these workers. So
Correct.
that's really interesting because obviously in the hackathon, it was open to use databases or whatever. It was, I think, encouraged to not use them. You ended up building a solution that does not use any databases, which would, I think, astound a lot of people who are used to thinking in terms of every microservice has to be stateless, right? Everything, your app tier has to be entirely stateless. There can't be any stateful anything in there. You can never store anything in memory, right? You're always talking to a database or to a cache or something. And this sort of inverts this and says, no, we're going to make everything stateful and we're not even going to use databases or caches or anything else. So I think that's going to be a very interesting shift in the way a distributed application developer thinks about building a system, because it's like all the old things that you could never do are the things that you should be doing. And all the old way that you were supposed to do everything, the stateless business logic, stateless app tier, and then rely on databases and caches for everything, you should not be doing in some sense. I mean, obviously you could still do them with
Yeah.
Golem. Nothing stops you, but also you're failing to take advantage of one of the most, I think, simplifying architectural enablements that Golem gives you. It's that durable state, which it's free. If you're not taking advantage of it, then surely there's tremendous simplification that you're just not going to be able to benefit from.
Yes, and don't get me wrong, it was also hard for me to, after microservice and distributed architecture experience here, right, to have this mind shift. But it's essentially
Yes.
right.
Yeah.
It's the right thing. It
Yeah.
feels right when you write the code.
It feels right. It feels awkward, maybe, and different to think about applications in this other way. But also, like, if we're thinking, does application development, is it always going to be the way we do things now? Or at some point, are we going to do things in a totally different and simpler way? And I hope the answer is yes. We're going to do things in a radically simpler way. And one of the things I think that durable execution platforms like Golem and other ones in its same category give us is that ability to just rip out all of these assumptions, which they add tremendous architectural complexity, code bloat, operational complexity, and infrastructure costs. It can't be cheap to maintain all of these different systems. It has to be very expensive and error prone. And Golem is basically, well, let's start from the assumption that your code would ever stop running, or that an in-memory data structure would ever not be around. It's just totally a different way to think about things that has the potential to radically simplify architecture. Now,
Absolutely.
I do want to talk about perhaps some ways we can improve this architecture, because I see a bottleneck right now, and that's the router. You said the router is a singleton worker, so there's one of those for the entire user base. So we've got, 300 million users all talking to essentially one node, one worker on one node. So that's a bottleneck. And I think if we're thinking about productionizing the Twitter backend that you've built, we need to address that bottleneck. So we need to have no more singleton worker that everyone in the world talks to. That means eliminating the router, or encoding the job that the router does in some sort of fashion that it's no longer this singleton worker. So let's think about that for a second. And Afzal, I think you can chime in with some thoughts there. But in addition to eliminating that singleton router worker, which is going to be a big bottleneck in this design. I mean, there's no bottleneck as far as I can see the way you've engineered it. There's no bottleneck in number of tweets stored, right? Because that's just going to be sharded, right? So you can store as much information as you want here. You can have as many users as you want. Fundamentally, though, everything has to go through that router currently. So that's the bottleneck we need to eliminate. Once we eliminate that bottleneck, then you're going to have the same sort of infinite storage capacity that you have now, because all this is horizontally scalable and whatnot. But then you won't have all of these different requests that are coming into the backend going through that singleton. So we need to eliminate the singleton router. We already have scalability in number of tweets and users and all that stuff. But I do think there's a way we can simplify it. Right now, the way you've designed it is that essentially you have a worker that stores a range of users' data, right? However, I think it's actually much simpler, and there's no reason not to do it, to say one worker per user, right? So every single user in the system, even if there's 300 million of them, that could be their own worker. Because one of the things Golem gives us is like workers that are not doing active work have no CPU and no memory, right? So they're not going to be costing us money to have 300 million workers, because there's only workers that are doing active work that are loaded into memory and consume CPU and RAM. So maybe number one, eliminate the router, which we'll talk about. Afzal, I'd like to hear your thoughts on that. Number two, have one worker per user to just simplify the logic that goes into maintaining that sort of hash map on every worker and whatnot. I think that would simplify it. And then I think if there's any other simplification that we would want to make, I think those are the main ones, those two simplifications.
There is another simplification I would probably do. It's aggregate. Aggregate all the manager's functions into one component. There's no need.
Okay. Yes. Yeah. Right. The third thing I was thinking about is right now you pre-compute the user's timeline. So I actually think that we can do way better than that by making that super lazy. Why? Because the average Twitter user is a bot, or maybe not a bot, but a semi-active user. You have the power users, and then you have like the long tail of people who check Twitter twice a week or whatever, and then you have the bots. So if you're pre-computing the timeline for all these bots and all these inactive users, etc., you're actually doing a tremendous amount of computation and storage that is never going to be useful, or almost never going to be useful. So I think flipping that around and making that super lazy, so that when I call, I'm this user, I am JD Goes, and my mobile client calls into this API that says, give me the timeline for JD Goes, that right at that moment, it's pulling together in chronological order everything I need to see, and maybe caching it on that worker, so that if I do it again a second from now, or my mobile client does a refresh or whatever, maybe it doesn't have to redo that work. But the point is, like, making that lazy, I think, can lead to a tremendous reduction in the amount of computation and storage that happens. Those are the three architectural improvements that I would want to make to this solution. So Afzal, give us your thoughts on, we have this, by the way, the router problem. Maybe we should dive into why this is a problem at all, right? Because I think when I'm thinking about how to architect this, if we just have one worker per user, then our API that we build on top of this can delegate to that worker, right? You have some, I don't know what it would look like, but like /JD Goes /tweets, right? And I can post there and so forth. And that can just go to my worker. So why do we need a router at all? Do we even need a router?
I don't think so. So if we have one worker that handles one user, and if we have a formalized way of hitting that worker nicely, maybe an HTTP API, which might be doing something more extra, which from a Twitter system perspective, we don't care, but you might be doing a little bit of scripting there, and being able to hit that one worker that corresponds to that user is all that is enough, in my view. And I think if at all we need to share the data across multiple workers for a user, probably it must be for a celebrity, keeping the list of all their followers. And in that case, I can spin up 5 more workers, and that one parent worker will know what are those other workers to get those
Yeah.
followers list. And I think that's the only place where, personally, when I was thinking about this problem, where the data sharing across multiple workers for a user, or I never thought about having multiple users in one worker, because Golem has enough toolings out there to hit the worker of one user. If you want to post a tweet, you know the worker that is responsible for that user. You post that tweet, maybe an HTTP call, which Golem has something called as a worker gateway. You can make use of that. And if you want to follow this, and following and having a timeline, there are various ways you can solve this problem, but all of that will still stick on to the fundamentals of Golem. Maybe we can discuss that later. What do you think? Is that reasonable, John?
I think, I mean, Danielle, you can feel free to chime in here, but I do think that if we have one worker per user, then all of the front end or mobile app requests that go into there, including get my timeline, post a new tweet, follow someone, unfollow someone, become basically functions on a user level component, and they end up delegating to, in the case of when I'm logged in, and my mobile app or desktop app, it calls into that API, they end up going to my worker, right? So if my worker is identified by my username, then it seems like the REST API, all it would have to do is make calls to that route with my username embedded into it. Or if we want to make things more stable, to renames, because Twitter allows you to change your username, then maybe there's one level of indirection here, which might complicate the architecture a little bit, which says maybe the mobile client or maybe the desktop client has to say, okay, well, as I'm logging in, I'm going to get back a user ID that's going to be stable for the life of my account. And then maybe that becomes somehow tied to the identity of the worker that is holding my data, holding my tweets, holding my follows, etc. And then the mobile or desktop client is always calling that worker's functions to get me back my stuff and manage my state. Does that seem reasonable?
Yeah, I actually, if I were to do it today, probably I will not use user IDs almost at all. I will use, simply the user handles. And I think it will be, we could have, let's say, an operation that if you want to rename your username, it just creates a sibling worker with that username and just propagates the data there, and that's it. Your other worker of the previous username will simply stay idle for the rest of his life. User IDs as well as hashing functions and router probably are over-engineered here. So if I would redo it with more clarity of mind, let's say, yes,
Yes.
I will remove them. Exactly. And I will also simplify the manager so that one manager handles one user and all its data. So
Yes.
you can tremendously simplify this architecture, actually.
So how long did it take you to build this Twitter backend clone?
It was 2 days, 48 hours almost of work.
So what you're saying here is that if you had it to do over again, you could do it faster because it's actually quite
Yeah.
a bit over-engineered for what we need it to be.
Yes, I think my microservice experience biased me in this implementation quite a lot, and I think we can even more simplify this architecture with the suggestions you also made.
Okay, so I think if we adopted this architecture that Afzal talks about, which is basically one worker per user, and then the routing is handled sort of on the API level. So anytime my client goes in to make some change, it's always going to my endpoint, which ends up being routed to my worker. Then we don't need a router singleton, right? So we've eliminated that bottleneck entirely. It's gone. And then also we've eliminated the sort of complexity of having this sort of map of user ID to user data, because a worker only ever has to store the data for a single user. So in that case, the data structure would be even simpler, right? It would be who do I follow, and what are my tweets, and where do I live, and that type of stuff, and maybe some authentication stuff as well. But it would be like very, very simple structure. And then the logic of that worker would just update that structure for that
Yeah,
user.
exactly.
And then we could also at the same time change it from push based, which is what you have, to pull based. So when you call get timeline for on this worker, it is getting the timeline lazily by basically calling out to all the other workers that store the data for all the people I'm following, and then doing some sort of lazy merge of the results only as little as is required with some level of caching. I think you could and maybe you would want to put some level of caching at the level of every individual worker, so that if I scroll forward and look at that stuff and I scroll back, no reason to recompute that stuff because it was already computed moments ago. And you could have some sort of I don't know, map, or maybe just like an array buffer or something, which stores a range of the timeline that's already been computed based on current follows and followees. And maybe that's invalidated or some from time to time, or maybe that's invalidated if you add a new follower or something like that. But
Right.
it seems manageable at the level of a individual worker per user.
I totally agree.
And then I think Afzal, you were mentioning that we might have to do something different for accounts that are following a huge number of users. Because obviously, when you get the timeline for a user that is following 2 million users, you can't query 2 million accounts. It's not feasible.
No, it's not feasible. Uh, but I saw a map where it says these are the number of followers for a user. It may not be applicable for all the users. And for celebrity homepage, I don't think Twitter either queries 2 million, 2 million, tweets from different, it's really hard.
Yeah, I don't even know exactly what they would do. But if there's
Yeah.
just a small number of those accounts, then maybe a push-based system would work better than pull-based. So you might have to specialize I think the architecture we've just talked about would work great for a small number of users. Like I don't know, I'm following hundreds to maybe thousands of users. It would probably work fine for that. It would stop working when you're following hundreds of thousands or millions of people. And you might have to design a different sort of architecture that is designed for the celebrity account.
Right. I think what Twitter does based on my research is that they go with both pull and push.
Yeah.
Yeah. So they fan out the tweets to the homepage of all of their followers um, in normal scenarios. And when it comes to celebrity, they pull the data and then join with the originally cached data. You can imagine fan out is caching the Redis or some other in-memory distributed cache, which is serving the data or the timeline for each user. But then that cache data along with the queried new data set is joined together and sent out. I mean, They are just details when it comes to
Yes.
system design with Golem. It doesn't like you can do exactly the same
It
here
seems
as the
like you can
backend.
do pull or push, right? It's like
Yeah.
Golem independent. The decision of whether to do
Yes.
pull or push is independent of Golem, and
Exactly.
you could choose either way depending on performance requirements.
Yes.
All right, so let's see here. What did Golem buy us in this case? Assume we make the improvements of eliminating the router, and then we come up with some sort of hybrid architecture that's a little bit more flexible in pull or push based on number of people you're following. Um, what did Golem buy us? What are some of the things that using Golem bought us?
Um, so Daniel was implementing a sharding mechanism, um, and that was a part of the entire implementation, which just took only 2 days. And he never talked about when implementing sharding, there was nothing about the availability, replications, or keeping a vector clock. What happens if something goes down? I mean, all of that is taken for granted. There is no consistent hashing. There is no strict quorum. There is no sloppy quorum. There is no other complexities that you need to think about when it comes to designing a complex system. And we don't even need to mention about Twitter. When it comes to Twitter, this just blows up. So for a distributed key value store itself, you have so much to think about. For a sharding mechanism, you have so much to think about, not just the components that you use. Like, yes, Golem already got rid of persistence layer. There is no need to even think like it's not persistence layer to solution. It's a solution first. And all you need to worry about is in memory, which is just data structures. You're literally talking about data structures that solves my business logic and
Yeah.
just deploy the applications. So already we got rid of persistence layer. But on top of that, in designing a system like Twitter or a distributed key value store, maybe Cassandra, for example, it requires a lot of thinking and a lot of concepts that you need to think through, and then all of that we're taking it for granted because of the features of Golem. I think it's pretty evident.
It's really fascinating just how much of a simplification there is in the architecture here. And it occurs to me that it's almost a bit like, okay, Golem becomes our database, right? Which means that our business logic is living with the data. And that just tremendously simplifies a lot of things, right? It's very complicated when your business logic lives outside the data, because then you have to encode your business logic, in some cases, parts of your business logic in SQL. But then when you move to the world of scalable or highly scalable architectures like Twitter, you don't have SQL anymore. So it's like the way you express that business logic in this convoluted language of Redis and Cassandra and this and that just becomes ever more ridiculous, and maintaining consistency is on you and so forth. And yet when you're leveraging Golem as a database, because everything in memory is just, you take it for granted that it's going to be there, and you take it for granted that your workers you don't have to monitor them. They're always there. They're always accessible, regardless of what happens. Then it really is like taking your ordinarily fragile business logic and just relocating it into the database. Or you could think of it the other way around, as like taking the database and bringing it up into your application, where everything is transactional and all state is persistent. It's a fusion of application logic and database that I don't think we've seen before, not in any mainstream way. No one's ever done anything like this in a mainstream way. I think now a number of players are trying to enter this space and build solutions for developers, but it really is something new, something the world has not seen before at this scale.
True.
Danielle, do you have any comments about what this buys us in terms of simplification?
Yeah, you absolutely saw since the beginning that the architecture was already way simplified compared to a traditional distributed architecture. And we also discussed how much we can still simplify it. And this is, I think, the groundbreaking revolution that Golem is introducing here. You essentially have your business logic, your data, and it's wrapped. Basically, you're wrapping that into Golem that provides guarantees that your data is safe along with your business logic. It simply sounds right to me.
Go ahead, Afsal.
Yeah, I would like to add the personally the most most fascinating thing for me working with Golem is being able to deterministically identify the worker that is concerned about a specific part of your computation, and that's not going to change. And there is no need for a separate sync job. There is no other need to create another API on top of the results that is synced from the worker to read the data, because you can literally expose the function within the worker. And while the worker is running, you can peek at it and identify what's going on. I think that's humongous power. Yes, we have so many other features, but this one is the most fascinating one for me, mainly because when I worked in data engineering spaces, that's exactly I was missing. Like when I was looking at Spark Job Monitor, I still don't understand what's going on because it's so much convoluted for me. Like there's so much graphs going on because Spark is running so much tasks, and you don't know which part of the data is taken care by what task. And when a task is going down, what exactly is happening? What kind of rebalancing is happening? There is no way you can or reuse a computation. For example, a previous Spark job was calculating a part of this computation already. So my next Spark job, can they just reuse that thing? It just doesn't happen because that task cannot be identified deterministically. With Golem, if you are simply solving that problem, basically rebuilding, I'm not talking about Spark, but I'm talking about rebuilding a completely separate system, solving the same problem. You can literally say that part of the app is taken care by that task, and I can peek at it anytime and identify what's going on. And I think that's my favorite part of Golem.
I think that's really interesting because for a lot of distributed applications, there is some sort of graph, right? Data is moving between edges of some sort of graph. And you see that here with Twitter, a node in that graph being a user, but also with Spark, like you have, fan out and fan in and mapping, all this other stuff. And one of the things that Golem lets you do is turn that graph into this sort of real life graph where workers are talking to each other and workers hold state, and it makes it explicit. And because it is explicit, because Golem gives you tools to look at those workers and see them and talk to them and query them and tell them to do different things, it just opens it all up and makes everything transparent. You can peek inside this graph representing your distributed application and you can do things with it. You can understand it better. And presumably that will, at least, as tooling is built around this sort of new model, it's going to tremendously simplify the aspect or the tasks of diagnosing problems or understanding what's going on or making sure that things are happening correctly or sort of ad hoc fixing some problem that's arising in production.
Yeah.
I think
And
there's
even in
another.
system, sorry to interrupt,
Go
John.
ahead.
Even in simple systems, cache hits and cache misses and distributed cache, and like when I was working as a consultant in dozens of projects, almost all of them kind of failed at it in some or other way. It's suboptimal. I can't say it's a failure. You have distributed cache, then you have machine specific cache, and then you have cache hits and misses, not to mention about the monitoring tool that is required to now report about the hits and misses, and the skewing that can happen, which result in so much load into the database system going down, at least in dev and prod, a couple of times a year. And I think that's a huge benefit when it comes to Golem. You don't have that problem that comes with indeterminism.
Yeah, that's right. Yeah. So the other thing and the last thing that just occurs to me on this theme of what does Golem buy us is surely Golem buys us some reduction in operational complexity. Like, what's the cost to operate and maintain a typical distributed system where we're using Redis and Cassandra and Kafka and all these different pieces? We've got microservice, we've got a service mesh, we've got all these different things out there. And we have to not just keep them all running and keep them all up to date, but then we've got to make sure we're doing best practice observability at every layer. And I think it seems to me that Golem is certainly trending towards a project that holds the promise of tremendously simplifying the operational story. Because I don't, it's not there today, right? There's not just one thing that you deploy, and that one thing is Golem, and it runs inside Kubernetes, but it's trending towards that direction. And I think for most shops that are using all this hodgepodge collection of different technologies, it probably is even now a tremendous simplification on operational complexity.
Absolutely. Yeah. You spend 2 days for the actual problem, and you spend hundreds just to make it reliable with operational complexities. And
Yeah.
Yes, I think everybody that had the chance to deal with real world microservice architecture knows that you can build the most reliable distributed architecture that you want, but when things go wrong, then good luck. And yes, of course, you can make your code um, resilient to the most of the things you can foresee, but there will be always something. The question is not if, but when, right? Your application will start failing. Then you will have to deal. I mean, all those components, Cassandra, Redis, that would be just against you in that moment because you will have to deal with the problem. And here, simplifying it, yes, maybe you have an issue somewhere with a worker, then you could even potentially just query that worker to understand that SQL worker to understand what's going on, and the CLI give you already some way to introspect into that worker and understand what's going on. It's really this was something that surprised me. Uh, it was my first time actually building something on Golem, and it was something that it was very surprising. And I think I can speak for all the other participants to the hackathon. It makes your application it makes you think about the essence of your application, not only
Yeah,
when you are building it, but also when you are running it.
that's interesting. Yeah, I think the operational sort of observability story of Golem just promises to be very high because you can actually look at things and they're there, right? Workers are always there. They're not consuming memory, they're not consuming CPU if you're not using them, but you can always look at them and you can try to understand what happened. You can poke around, you can talk to them through their API defined by the component they were created from. And I know lots of great stuff is coming in the future, like rewinding a worker and restarting from a different point, or debugging it and sort of stepping through its execution, and all that stuff is sort of powered by the same technology that enables Golem to give you automatic fault tolerance. So it'll be interesting seeing how this open source project develops. All right, we're going to wrap up. So Danielle, you've won 2 hackathons in a row with Golem. I'm sure some people have gotten intrigued by watching this and are wondering, like, what's the secret? Like, what can we do better to prepare for the next Golem hackathon, which will be next year at Durable Computing World, probably? What's the trick to winning these things?
um, well, I still don't know, but if there is something I can tell you is to try to fully understand the requirements before jumping into code. This is something that always helped me in my experience. And of course, when it comes to hackathons, prioritize your MVP. So you can always polish later and refine details later. And when your design choices don't go as planned, because very likely you will have some things in 48 hours implementing Twitter that you didn't foresee, then is a key to keep calm and be ready to give all your design.
Makes sense. That makes sense. And Afsal, so I think hopefully people have been a little inspired to learn more about Golem, to become familiar with it. What do you recommend if people want to get more hands-on experience architecting applications for Golem and just learning how you think about distributed systems when you have this superpower of durable computing? What's a way they could take their skills and knowledge to the next level?
Okay, I can share what I did when it came to Golem. Like it's a self-evaluation plus understanding Golem and understanding what's there in the world, right? It's we don't know the entire complexities of all the systems out there, so you got to learn. What I did was being able to implement a distributed key value store using classic system design. What are the complexities involved? I recommend the book Alex Wu first edition. I can't remember first edition or second edition. There must be one, which has around 7 to 8 chapters around various concepts of most of the complex system design concepts, like I mentioned before, like all the consistent hashing problems, all the way things are calculated to conclude what is your position in the cap theorem, of your system. Is it CA or AP or CP? And then going all the way to actually implementing a distributed key value store using classical system design. Can you build a DynamoDB? What is involved in it? And then come back and see what's with Golem. I actually implemented a key value store. I think I mentioned it to you, John. I implemented a Golem timeline, which is very far superior compared to a key value store. So I always publicize and talk about Golem timeline. But we don't even need to know about Golem timeline and its complexities. But just a simple distributed key value store can sort of give you an idea of how much Golem can give you. And I think as I mentioned, recommend Alex Wu's book because it literally talks about the complexities. Otherwise, we just think about, yeah, it's a key value store. I need to replicate and that's it. No, there are so many things that needs to be considered. And then you can see all of that getting eliminated when it came to designing a worker using a component, what should be the entity of each worker and how much I can do with it. And that's when it comes to Golem.
Fantastic. Great advice. I think as people learn more about like the theory of distributed systems engineering, obviously people are building these systems today, in many cases without the theory, but when they have the theory, their brain starts to work in different ways and they understand all the different failure scenarios and the implications on consistency for the entire application state, which these days is distributed across databases and queues and third-party APIs and all these different places. And the inconsistency can be very costly for some businesses. I think a lot of businesses, inconsistent data across these different systems leads to some additional cost. It could be very high in financial space, or it could be less high, but getting familiar with the theory of distributed systems engineering helps you think about things like that and understand just how complicated solving them is. And even the simple exercise of like building or at least architecting a distributed key value store will teach you a lot about how to think in ways of how do we ensure our system, which is distributed, is correct. Because many developers are not even thinking about correctness, right? They just call these APIs and creates problems for people that have to be solved with SQL stuff and ops time and DevOps and all that stuff. But it teaches us to think in terms of we actually can build correct systems that are distributed. We just have to be super careful and pay attention to all these different things. And then once you go from that world of high knowledge and high skill over into Golem, you're saying it's like, wow, all these things that we had to pay attention to, no more. It's just a totally different world and gives you an appreciation for how much Golem brings to the table, which I think is good advice.
Yeah, exactly. Building any application these days, from a use case perspective, sounds simple, but to make a production grade, bug-free, reliable application, scalable application, that's a different story. Yeah.
Well, hopefully one day in the not too distant future, it's going to be quite simple thanks to technologies like Golem and other solutions in the same space.
Exactly.
All right. Well, thank you so much, Danielle and Afzal, for joining me. This was a fantastic conversation. And I think what we'll do is, for all our viewers out there, we do have a Discord. Hop on over to the Golem Cloud Discord, and we'll post a few links in there. We'll post a link to Danielle Torelli's solution. We'll post a link to Timeline from Afzal Faj so you can better understand how to build a real system with Golem. And we look forward to your feedbacks and your GitHub pull requests and your issues. And don't forget, actually, right now, as we speak, a variety of open source contributors are hard at work building a new feature into Golem. This is part of our Bounty to Hire event. And the deadline for submitting your pull request is Monday. The winner is going to get 15,000 and maybe a new job. So we'll see. But anyway, check that out come Monday. We expect a lot of solutions to be posted. And then roughly a week from then, we're going to go ahead and have a winner event. So we'll talk about all the different solutions and which one is winning and why. And hopefully we'll also be able to announce a new team member joining Golem Engineering based on this Bounty to Hire program, because that's going to be exciting. We have lots of work to do on this open source project, and we need more bodies to help out. So see most of you there, I hope.
Thank you
All
for
right, take
having
care,
me.
everyone. Yes, thank you, and see you soon.
See you soon.